Hello and welcome, everybody. Can I get some hello in the chat? Where are you hailing from? What's your time? Is it a good morning? Is it good noon? I learned yesterday that there's a term good noon, but nobody uses it. So I would say good noon, good afternoon, or good evening. You can post in the chat so we can see where all the participants for this talk come from. Finland. Yeah, that's what I thought with the name. Cool. Thank you. My voice is a little bit damaged today, so I will hand over to our brilliant guest keynote speaker, Christian Baumann, immediately to take care of my voice. I think you are here to hear his cool talk about don't be a fool with a tool, which is already really promising from the title wise. Christian is a principal test architect and, you guessed it, conference speaker. That's why he's here, obviously. And hello, Christian.
Hi. So, should we jump right into things?
We can jump into the slides. I would ask you, how do you want to have your questions? Do you answer them in the chat, or should we collect them, interrupt you?
No, maybe collect them and then we'll go through the questions afterwards. Because
Oh.
when I'm in the flow, it's hard to interrupt me.
Yeah, I know that. Okay, cool. Then
But
I give the stage to you.
Okay, let me share my screen.
And also, while Christian is sharing his screen, we have reactions in Google Meet now. I think they're about a month old, so feel free to use them. And they show up on the
that
screen.
Seems to work. Okay, I guess you can see my screen.
Yes,
at least it's cool. So, hello and welcome to my talk. Don't be a fool with a tool. Fundamental knowledge for proper test automation. Thanks everybody for joining in, and a special thank you to the nice Ask UI people for inviting me. My name is Christian Baumann, and I'm a software tester at myborn-Wolf. In my free time, I like spending time with my family, reading fantasy books, riding my motorbike, learn about testing and coding, and I also play the clarinet and the saxophone in a band. And Lego even made a minifigure out of me. For more info about me, you can check out my Twitter and Mastodon. There's a link to my different profiles in my bio. Let me explain you what this talk is about. Many people get into test automation without having a profound background in programming or without receiving any proper training. They have some idea about what tool to use, gathered some basic knowledge, and managed to create some automated tests with it. At a certain point, they suspect that something is not quite right with their automation. The code feels messy, maintaining it is hell, costs a lot of time, and is very frustrating. Don't worry, this talk has you covered. I'll talk about test automation strategy, test data management, object-oriented programming principles, code smells, the idea of clean code, and design patterns in test automation. Basically, I cover the things I wished I had known more than 15 years ago when my test automation journey began. Each of these topics is huge, so this talk cannot cover them all in detail, but it is intended to give you some hints and starting points for further studies and research. Way too often, people immediately jump into coding their test automation without having a strategy or plan at hand. And usually, this leads to a lot of problems. So, what about a strategy or a test plan? Or maybe both? But what's the difference between a test strategy and a test plan? Or are they just different words for the same thing? According to the black box software testing definition by Kana and Buck, a test strategy answers the question, giving a testing mission, how will you achieve it? Where they define strategy as the set of ideas that guide your test design, logistics as the set of ideas that guide your application of resources, and plan as the combination of your strategy, your logistics, and your project risk management. Having a strategy and plan in place for your automation helps to eliminate a lot of unclarity and guides you throughout the project, and thus reduces the chance of failure. Asking questions helps you to formulate your strategy and plan. What is the goal for the test automation, and what shall be accomplished? What should be tested? Who should do the automation, and in what capacity? How to plan for the execution of the strategy? How to test? When to test? Where to test? Also, models can be of great help when formulating a test automation strategy or a test strategy in general. According to Michael Bolton, good models are a set of guidelines to help us solve a problem. This is also true for test automation. Common models used to guide your test automation are the test automation pyramid and the automation wheel. There are more, like the software testing ice cream cone or the agile testing quadrants. But please keep in mind that models are not reality. All models are wrong, some are useful. Let's talk about test data or test data management and the differences in test data management when automating your tests and when testing manually. When testing manually, in most cases, the test data is entered by the tester on the fly, mostly shortly before or even during the test execution. Either the tester knows which data is required to execute a test, or it is mentioned as a precondition in the documentation of the test. This on-the-fly approach is not feasible for automated tests. Automated tests rely on certain data that they require as a precondition for successful execution. Imagine using a shared test environment, and the automated tests assume a certain set of data to be available in the system. In case someone modified or deleted that data, the automated tests will fail. I guess most of you have experienced this before. And I think we all agree that this is a no-go, and thus, for automated tests, you need to have your test data under control. I'm simplifying here, but in general, there are two commonly used approaches to ensure your automated tests have the data available they rely on. Approach 1, you ensure that all data for all tests is available in the system upfront, either on database level, e.g. by loading a certain backup, or by running a script prior to the test execution that inserts all necessary data into the system. Or approach 2, each test creates its very own data as part of its test setup. And also, after the execution, all created data should be deleted again to not pollute the system under test. Which strategy of managing test data you choose depends on your project and environment. Next, let's talk about the 4 basic principles of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. Let's have a closer look at each of them. Say we have a program. It has a few logically different objects which communicate with each other according to the rules defined by the program. Encapsulation is achieved when each object keeps its state private inside a class. Other objects don't have direct access to this state. Instead, they can only call a list of public functions called methods. So the object manages its own state via methods, and no other class can touch it unless explicitly allowed. If you want to communicate with the object, you should use the methods provided, but by default, you cannot change the state. Abstraction can be seen as a natural extension of encapsulation. In object-oriented design, programs are often pretty large, and separate objects communicate with each other a lot. So maintaining a large code base like this for years with changes along the way is difficult. Abstraction is a concept aiming to ease this problem. Applying abstraction means that each object should only expose a high-level mechanism for using it, and this mechanism should hide internal implementation details. It should only reveal operations relevant for other objects. You see, other people not working in IT have recognized the concept of abstraction as well. In object-oriented programming, objects are often very similar. They share a common logic, but they are not entirely the same. So how do we reuse the common logic and extract the unique logic into a separate class? One way to achieve this is inheritance. It means that you create a child class by deriving from another parent class. In this way, you form a hierarchy. The child class reuses all fields and methods of the parent class, which is the common part, and can additionally implement its own unique part. So we already know the power of inheritance, but there's a potential problem. Let's say we have a parent class and a few child classes which inherit from it. Sometimes we want to use a collection, for example, a list, which contains a mix of all these classes. This can be solved by using polymorphism. Simply put, polymorphism gives a way to use a class exactly like its parent, so there's no confusion with mixing types. But each child class keeps its own methods as they are. This typically happens by defining a parent interface to be reused. The interface outlines a bunch of common methods. Then each child class implements its own version of these methods. And anytime a collection or a method expects an instance of the parent, where the common methods are outlined, the language takes care of evaluating the right implementation of the common method, regardless of which child is being passed. So on a really high level, we can say encapsulation means hide the data. Abstraction provides templates to be implemented. Inheritance can be shortened to extend data and behavior. And polymorphism is the ability to take multiple forms. Applying those principles in your test automation code will be of great help and make your life much easier by making your code easier to read, understand, and maintain. Angie Jones has a great talk with examples on how to apply object-oriented programming principles in test automation. And a link to that talk can be found in the resource section of the slides. Let's talk about code smells, but actually not this kind of smell, but more like this. But what are code smells? One way to look at smells is with respect to principles and quality. Smells are certain structures in the code that indicate violation of fundamental design principles and negatively impact design quality. Code smells are usually not bugs. They are not technically incorrect and do not prevent the program from functioning. Instead, they indicate weaknesses in the design that may slow down development or increase the risk of bugs or failures in the futures. Code smells can be an indicator of factors that contribute to technical debt. Let's talk about a code smell example, the long class. The class at the right has nearly 500 lines, and it probably isn't the longest class that exists. Still, it causes some problems. There's no single responsibility. Instead, it's taking too much responsibility. It's hard to find things. It's difficult to maintain. There's a lot of private nested code, which is hard to unit test because it doesn't have a public interface. And it does not fit in my head. Martin Fowler, who provided this real-world example, says about this class, it's bloated and convoluted and impossible to fit in my head. This has created a nasty feedback loop. Because this code is so hard to reason about, refactoring will take more time and energy than I have. So I'll put up with it even longer, even though it means I can't even make small changes anymore because it takes so long for me to understand the code's current state and decide where the change should go. Sorry. Another code smell is too many arguments. This means an object or method needs too many arguments to work. Problems that too many arguments cause are low maintainability, low reuse, and coupling. This is an example of too many arguments. But how to solve this? This is one possible solution. In order to achieve it, you should relate arguments and group them. You should favor real-world mappings. That means how the things, the objects are grouped in real world matches how to group the argument in cohesive objects. If a function gets too many arguments, some of them might be related to the class construction, which is a design smell too. Since coupling is a potential side effect of the too many arguments smell, let's talk about coupling next. Tight coupling is when two objects are so dependent on one another's data and/or functions that modifying one requires modifying the other. When two objects are too tightly coupled, making changes to code can be a nightmare, and you're more likely to introduce bugs with every change. In this case, worker and bike are tightly coupled. What if one day you wanted to drive a car instead of a bike for your commute? You'd have to go into the worker class and replace all bike-related code with car-related code. That's messy and prone to errors. You can loosen coupling by adding a layer of abstraction. In this case, the worker class doesn't just want to drive bikes, but also cars and maybe trucks, possibly even scooters. These are all vehicles, aren't they? So we create a vehicle interface which allows to insert and replace different vehicle types as desired. By the way, this is an example for polymorphism. Duplicate code means you perform the exact same logic in multiple, unrelated areas of your program. Later, you realize you need to modify that logic, but you don't remember all the places where you implemented it. You end up changing it in only 5 out of 8 places, resulting in buggy and inconsistent behaviors. Duplicate code is a prime candidate for being turned into a function. For example, let's say you're developing a chat application and you write this. Somewhere else in the code, you realize you need to perform this very same "is this user online" check. Instead of copy-pasting the loop, you can pull it out into a function. Now, anywhere in your code, you can use the "is user online" check. If you ever need to modify this logic, you can simply tweak the method and it'll apply everywhere it's called. One of the symptoms of object-oriented programming is to use switch statements or a cascade of if-else statements with a type code to get different behavior. Switch statements bear the risk of duplicated code, and they are an anti-pattern to the open-close principle, which states that entities should be open for extension but closed for modification. Imagine that we have some client class that calculates the area and perimeter of particular geometrical figures. This code is clearly a poor design that limits the current client to only work with 3 types of figures. There are usually several places in the code where the behavior slightly deviates and these switch statements are present. For example, in the calculate surface and calculate parameter methods. This is even worse if we work with objects where the switch is replaced by multiple instances of if conditions. To improve the design, you can make square, rectangle, and circle have a common root, meaning that they either extend the same class, such as abstract figure, or that they implement a common interface, such as figure. Then you can eliminate the switch statement code smell very easily. You replace it with polymorphism. And such refactoring simplifies the client code. It also allows for easy extensibility by implementations of other figures without changing a single line of client code. Another way of looking at it is from the responsibility point of view. Why should the client be responsible for calculating the area or the parameter, or having knowledge about a figure's internals, e.g. the number of sides, the radius, etc.? This is the responsibility of each figure, and all the client needs to know is that a figure has a parameter and area. So using polymorphism not only helps to avoid coupling, but also can overcome the switch statement code smell. Other types of code smells are not communicating the intent, comments explaining hard to read or hard to understand code, and plenty more. Code smells can be avoided by applying object-oriented programming principles as well as clean code principles. Clean what, you might say? Code is clean if it can be understood easily by everyone on the team. Clean code can be read and enhanced by developer or test automation engineer other than its original author. With understandability comes readability, changeability, extensibility, and maintainability. Clean code consists of rules and principles to follow in order to achieve clean code without smells. Martin Golding's famous quote is, "Always code as if the guy who will ultimately maintain your code will be a brutal psychopath who knows where you live." Writing clean code makes it easier to understand the code and is necessary to create successful test automation code that you can maintain. Programmers are authors, and your target group is not a computer. These are other programmers and you. To quote Martin Fowler, "Any fool can write computer understandable code. Good programmers write code that people can understand." To be able to write clean code, you should train your mind for some time. The hardest part is just the beginning, but as time goes on, the skill set gets better. Writing clean code is readability, so even the smallest things, such as changing your naming habits, make the biggest difference. Let's do a quick check on the concept of readability. Both code fragments do exactly the same. Which one do you think is better in terms of clean code? You now have to answer this for yourself. On a live talk, I can always ask the audience. It's clearly the second one. It's a bit longer, but it can be easily understood and read, nearly like natural language. According to the clean code idea, there are some general rules to follow. Follow standard conventions, use meaningful names, KISS, keep it simple, stupid, the Scout rule, and many, many more. Let's have a closer look at some of them. Let me quote the clean code book on following standard conventions. Every team should follow a coding standard based on common industry norms. This coding standard should specify things like where to declare instance variables, how to name classes, methods, and variables, where to put braces, and so on. The team should not need a document to describe these conventions, because their code provides examples. Everyone on the team should follow these conventions. This means that each team member must be mature enough to realize that it doesn't matter a whit where you put your braces, so long as you all agree on where to put them. Names are everywhere in software. We name our variables, our functions, our arguments, classes, and packages. We name the directories that contain them. We name our jar files and war files. We name and name and name. And because we do so much of it, we'd better do it well. I will only present a few rules for naming. You can find more of these in the resource section of the slides. Use intention revealing names. It's easy to say that names should reveal intent. Choosing good names takes time, but saves more than it takes. So take care with your names and change them when you find better ones. Everyone who reads your code, including you, will be happier if you do. Use pronounceable names. If you can't pronounce it, you can't discuss it without sounding like an idiot. Well, over here on the BCR3CNT, we have a PSCKY integer, see? This matters because programming is a social activity. Class names. Classes and objects should have noun or noun phrase names like customer, wiki page, account, or address parser. Avoid words like manager, processor, data, or info in the name of a class. Also, a class name should not be a verb. Don't be cute. Will they know what the function named killemall is supposed to do? Sure, might be funny, but maybe in this case, delete items might be a better name. Choose clarity over entertainment value. Say what you mean what you say. KISS, keep it simple, stupid. A design principle originating from the US Navy that goes back to the 1960s already. It states that most systems should be kept as simple as possible. Unnecessary complexity should be avoided. The question to ask when you're writing code is, can this be written in a simpler way? Simple code is less prone to bugs and is easier to read and understand for you and the people who will be working on the code in the future, including yourself. Keeping things simple is, ironically, not that simple. It requires abstract thinking. It requires knowledge of the domain you're working on. It requires knowledge of the code, the framework, and the language you're working with. And it also requires experience. Next rule to discuss is the Scout rule. In the literature, this is often referred to as the Boy Scout rule, but as a lady at my last talk pointed out, there's no need to include boy here. And as it's International Women's Day, I think it's good to point out that should be named the Scout rule in the future. So the Scout rule says, always leave the campground cleaner than you found it. When you find a mess on the ground, clean it. Doesn't matter who did it. Your job is to always leave the ground cleaner for the next campers. For programming, this can be expressed as always leave the code cleaner than you found it. Meaning that every time that we make a change in our code base, we make an improvement in the code. There are many ways to apply the Scout rule to your code. And it doesn't have to be something big. You can rename a variable to a more meaningful name. You can get rid of a small duplication or break up a long function. There are some more principles and rules to follow, such as try, don't repeat yourself, the solid principles, the source code structure, and many, many more. Next topic I want to talk about is design patterns. A design pattern is a general, reusable solution to a commonly occurring problem within a given context in software design. Design patterns can speed up the development process by providing tested, proven development paradigms. They also help to prevent hidden, subtle issues that often are detected only late in the process. Furthermore, they also improve code readability for coders and architects who are familiar with the pattern. I'm sorry. Maybe the best known design pattern in test automation is the page object model, or in short, POM. It models the application under test and thus keeps the tests independent from the implementation details of the software under test and reduces maintenance efforts when the application changes. The screenplay pattern fulfills a similar purpose. It aims at writing tests like screenplays by structuring complex test code in a way that makes it more readable, reusable, and maintainable. It does that by taking a user-centric and object-oriented view on things. In screenplay, a user is represented by an actor. Actors can have abilities, and abilities enable them to do tasks or answer questions. In screenplay, each of these concepts, actor, ability, task, and question, are objects which abstract from the actual actions. The object mother pattern is used for test data generation. It starts with the factory pattern by delivering prefabricated test-ready objects via a simple method call. It moves beyond the realm of the factory by facilitating the customization of created objects, providing methods to update the objects during the tests, and, if necessary, deleting the object from the database at the completion of the test. Some reasons to use object mother are reduction of code duplication in tests, thus increasing maintainability. Test objects are super easily accessible. Every test runs with fresh data, and tests always clean up after themselves. This was Don't Be a Fool with a Tool, fundamental knowledge for proper test automation. Before I close the session, let's quickly recap what I presented. First of all, have a strategy. Asking questions and using models can help to build it. Manage your test data properly. Following object-oriented programming and clean code principles and using design patterns help a lot to avoid code smells and make your code more maintainable. As said, in the duration of this talk, I could not cover the topics in detail, but that wasn't the purpose of the talk. The intention was to present strategies and approaches to make your test automation successful, and you can further study and research these topics on your own. I will share the link to the slides on Twitter and LinkedIn, and at the very end, there's a resource section with links to articles and talks for your further learnings. This was my talk. Many thanks for your attention. I hope you found some useful bits for your work, and I'm happy to answer any questions you might have.
Thanks, Christian. I really love the Scout rule myself. So the Scout rule is my number one rule in clean code. So
yeah, it doesn't cost you much.
Yeah, it's easy and fast and makes everyone happy, I would say. We have a lot of questions, so let me scroll the chat. So the first question is more like an organizational one. Do we have the slides anywhere?
Yeah, as said, I would publish them on Twitter, on LinkedIn. I can send it also to you, and you can publish it also via your social channels. Sure.
Thank you. I had to get something to drink, so I missed that part. Unfortunately, sorry for that, but it was a question in the chat, so somebody joined later. So, okay, where is the first questions? Wille, I hope I don't butcher the names here. I think that was a question at the beginning. He asks approaches to untangle a mess that is already there. Maybe you have to clarify what exactly that mess is.
Yeah, I was referring to the mess you showed on your first slide. Kind of asking
cable
points or hinters what to do when you arrive to such a place, if you know what I mean.
Yeah. So basically, the first step is to know existing code smells, to know the mess, because this is kind of patterns that repeat over and over again. It's always or very often the same or similar things that you see. Like for the example with the figures where you have different, where you do all in one big class, and then you can use polymorphism to entangle that. So the first step is to know the smells, and then there's per smell. You can find a lot of resources online on that. Per smell, there exist refactoring techniques on how to get rid of the smells. So if you recognize something as to be a long class or a long method, or you see the switch statement code smelled, there is patterns, there is methodologies, refactoring techniques for nearly every smell that is there. So first step is recognizing and identifying the smells, and then applying the appropriate refactoring technique.
Okay. I also know a book that's called Refactoring. I think there's a new edition coming out, which is a very descriptive book name, I would say, book title. Then we have another question from Jan. He asks, can there be more than one actor in screenplay pattern?
Yes, of course. And you can match them with the concept of personas, or that they have different rights or whatsoever. Yes, absolutely. That's actually the idea of having these actors, because this is something that PageObject, for example, is not able to handle. You have different actors, these have different roles, and you model that via assigning different abilities to them. So an ability could be to, I don't know, create new users, or I don't know, update a website or a content management system, what a normal user can't do. Yes, they absolutely can model different users.
Okay.
Or different actors.
Yeah. Jan, unmute yourself. Perfect. Then we have, oh, no, that's hard. Marosh, I think that's how you pronounce it. What is your opinion about keyword-driven or action-driven approach to test automation design?
Okay, so having keywords or action-driven or table-driven, whatever you call it, and it's not so much different if it's no code or low code. What you do by this is you add a layer of abstraction on top of your test automation code. So this has the advantage that it's easier for non-technical people to use. It is. On the other hand, it comes with the limitations that by adding this abstraction layer on top of your test automation code, you also have, how to say, less possibilities, and you don't have everything that the programming language provides you on this higher level. It's less mighty, so to say. And this is also kind of the drawback. You cannot do everything with that. If you are aware of these limitations, it can be a useful approach, and I've seen it work. But what you always should keep in mind is that it's an additional layer of abstraction. You abstract the complicated stuff away, and therefore cannot do everything like with directly in code.
Okay.
Hope that answers the question.
Marosh still there? Maybe a thumbs up. Okay. Yeah, cool. Thank you. Then Wille asks, how to fix a problem where tests modify test data other tests depend on?
Yeah, okay. I presented these two strategies of test data management, and I'm clearly a fan of the second one, where each test is responsible for its very own data. This means that you have at the very beginning, you have a test setup where you create all the data you need, insert that in the system as a precondition for the test. You need certain data to be available in the system. I don't know if you have a hospital information system, you need to have certain doctors and nurses and patients and medicine that needs to be in the system that you then can use during your test case. And ideally, in the teardown phase at the very end, you delete the test data again. Not just what you created in the setup, but also what you created during the test execution. That's the cleanest approach, and I would always advise to try to use that. On the other hand, I know that there's a lot of projects, a lot of contexts where this is not feasible because you don't have access to the APIs, or not even speaking of accessing the database directly to insert test data there. Then the first approach is more of the way to go. Then you need to discuss with the whole project and maybe even get the test environment engineers or the database administrators with you on board to clarify what test data you need. And you also need to find a way to ensure that nobody else is is accessing or modifying the data you need for your automated tests. Then a bit more process is involved if you cannot solve all of it technically.
Okay, if nobody wants to unmute his or herself, themselves, that's the perfect way to say it. I had some questions also in the chat, but I wanted to have the questions from the participants before. So you didn't mention a code formatter or linter. What's your opinion on those?
Yeah, code formatter can be helpful. You need to, I mean, that's what Uncle Bob says on clean code, on coding standards, and so on. You should have that in a team because then I think easier for everybody. If traces are set on the same layer, so to say, if you use tabs or spaces, in the end it doesn't matter so much, but you should agree on something, because then it's easier to I think it increases readability if all apply the same coding styles. So yeah, it should be used, I think. And then auto formatting helps you with that. You can, it's way easier that you automatically format your code into the team standard.
Cool, thank you. One last question I had when I heard about the page object model pattern and the screenplay pattern. What is your favorite pattern of the two?
I always have to say it depends. So the issue, page object has a couple of issues. So when it was invented back in the days, like 10, 12, 15 years back, when Selenium became like really, really popular, a lot of people joined the test automation space without having proper programming knowledge. And page object was one way back in the days to make it easier for these people to get into the test automation space. The problems is page object doesn't follow the solid principles. So you have it already starts with single responsibility. Usually you have methods that execute stuff on the page, but on the other hand, you also have locators in the page object. There's other shortfalls. On the other hand, screenplay is following all these principles and conventions I presented. On the other hand, it's a lot of effort. If it's just a small project you're working on, screenplay probably is too much. It's using cannons to shoot at sparrows. So again, it depends. If you're aware of the negative things of page object and your project is like really, really small, then totally fine, go with it. But if you have something really advanced, I would advise screenplay. The other thing is page object thinks in pages, but not all of your test cases, not all of your user flows are happening on a single page. So you anyhow have to combine several page objects in a flow. Oh gosh, there was another thing I wanted to mention. I forgot. No, in general, principles, abstraction, patterns in general, it's a good thing to use and you should aim for that, but not for the purpose of just following a pattern. Sometimes there's no rule without exception. And sometimes it makes more sense to take a way that is not as clean, that is not by the book, but it makes more sense in your context. So that,
Cool.
don't blindly implement what's written in the textbook. You also should think and clearly and make decisions based on your context and what makes sense for you.
Yeah, cool. It depends, really. Thanks for the elaborate answer. Really insightful to get your opinion there. I don't see any more questions in the chat. So before I wrap it up, I want to plug our Ask UI hackathon here. This event with Christian is part of the Ask UI hackathon. You can still sign up and participate for total prize money of 900 euros. We also have a Discord community around Ask UI. Apurva posted this in the chat already. And thank you again, Christian, for joining us and giving us so many insights about don't be a fool with a tool.
Thanks for having me.
And
my pleasure.
For that, we will release the recording as soon as possible. The session was recorded, and maybe also the slides. But Christian will also take care of this. So
yeah,
happy hacking for how the hackathon, and see you maybe tomorrow for the Ask Me Anything with our team.
Bye-bye.
Thank you.
Bye-bye.